Hooray! Welcome to lesson 11. Let's look at enhanced application security capabilities. Now, if you look at the structure of the training, exam prep all the while, you will see that it's tied towards the objectives. If you watch the objectives, you will see that there are certain things that you should be expected to do. At times, you are told, "Okay, explain." If you want to explain some concepts, what are you supposed to do? At times, it's to enhance. At times, it's to be able to differentiate. At times, in the curriculum here, you see things like define. Here, we're looking at application security capabilities. We've looked at mobile. We've looked at network. We've looked at cloud earlier on. So, but now we're looking about the applications, of course, on the layer 7 of the OSI model. We're looking at all of the softwares we're going to be using in our enterprise. How do we ensure that they are secured? Okay, let's look at security baselines. Now, first of all, when your applications communicate, how do they communicate? Here, we want to look at different types of protocols and how do we ensure that we have the protocols that are secured, and you want to be able to differentiate them. That's why if you use some testing tools, it will give you a report and say, okay, this guy is running the plain text protocol and it is not advisable. It gives you some recommendations, especially when you're doing web vulnerability assessment. Now, many of the protocols used today were developed many decades ago. Some of them in their late 80s, early 90s, during the internet age, when the internet started coming out and started having a lot of applications. Now, as at that time, functionality was actually the key stuff, not security. Because we want to be able to communicate, want to be able to use something. Usability was the goal, not necessarily security. But as time went on, we needed to actually make sure that our conversations are secured. So we now start talking about secure protocols and unsecure protocols. As a task, as an assignment for your exam preparation, you could have a list of 20 insecure protocols and their alternatives. That's to say, and their secured alternatives. Then while you're researching that, you can also look at the application of those protocols, their port numbers, and that will help you a great deal in understanding communications. And of course, you could differentiate them between TCP and also UDP. That is connection-based protocol and connectionless-based protocols. Now, TLS is most commonly used secure HTTP communications, can be used for VPNs. It has several versions. It used to be SSL before it became TLS. I think it was maintained by, what was the company again that actually maintained the SSL? But before it was not given to the IETF, the Internet Engineering Task Force. So I think our latest version now is, I think it's about 1.3. The earlier versions were done, most of the algorithms were done by mathematicians. So some flaws before the IETF now started maintaining it, and we have this particular version. So you should use only TLS version 1.2 and newer, that is a 1.3. These two things can be used interchangeably, but the right word is TLS because SSL was the older version, that is secured sockets layer. Now, in cryptography, we talk about ciphertext. So we have a cipher suite, which describes a mix of algorithms used to implement TLS protection. So here, we're not just trying to talk about one algorithm. So it's a mix. So because TLS is going to help us do especially web security, I think this is a capture from Wireshark. Okay, yes, viewing the TLS handshake in a Wireshark packet capture. Know that the connection is using TLS 1.3, and one of the shortened cipher suites is TLS, AES, GCM, SHA-256. So it's a combination of algorithms. You should know that TLS has an algorithm, AES has, GCM has, SHA-256, which is a hashing algorithm. So this makes TLS possible. Now, secure directory services. Now, you know, for every network to be able to see stuff, have access to items within your network, there must be a way to be able to identify all of the different computers, all the different users, all of the different directory, all the different files. So what makes that happen is a network directory system or network directory service. So we were trying to say, okay, how do we make sure that we have a secure system? Just understand that LDAP default is clear text communication. That is lightweight directory access protocol. Now, I did a small table here that talks about what a directory service is. You can pause the video and follow up. What type? We have two major types, the LDAP, the Kerberos and Active Directory. There you have the different case studies. LDAP being defined here, have its case study in SSL TLS, right? Now, for every network will need to be managed. So what suite helps us to do all of the pinging, monitoring, send message back and forth, monitor what is happening with respect to time, with respect to packets being sent and all of that. So the simple network management protocol does all of those stuff. Management, monitoring, right? So this helps us to, this can also be used to issue commands. The latest version is version 3, which gives us the best secured feature. Other and older versions should be avoided. Another service we have is the FT or file transfer service. Most commonly used the FTP, but note that you have SFTP. For instance, this is going to be on 443, this is going to be on 20, and this is going to be on 21 or 22, depending whether it's going to be a server to a server or a server to a client. So, like I said, for a task for your exam, you want to be able to have plain text protocols, secure plain text protocols. That's their alternatives, their application, the port numbers, the protocol, and their application, right? It's a very good thing to have in your notes to help you prepare for the exams. Okay, for email service, the service here is SMTP, that's port 24. And you have the different services that can be using, I think 193 thereabouts. So there's difference between POP and IMAP. Okay, sorry. IMAP is 943. Yes, 943. That's for IMAP, and POP3 can be listening on 10100. So depending on your environment, if you're configuring a mail server, you're going to have those instructions when you set up the server. It's going to give you the port numbers for that particular email, right? So an email service is going to be hinged on a DNS, on a domain name service. So take, for instance, I have SOUTECH-Ventures.com, right? The SOUTECH-Ventures.com on plain text is going to be running on port 80. So all the communication between the browser, if I fill a form to the server, is going to go through port 80. If I implement TLS, the communication is going to go through port 443, right? So that's web communication. When it comes to email, let's say I want to have something like victor@SOUTECH-Ventures.com. Normally, once I set up that email, I will have an instruction that will tell me, okay, if I want to use this email or maybe an email client, or I want to use this email on a phone or somewhere else, these are the instructions. So it will set out all of the, what's it called? All of the configurations, all of the port numbers to use, whether you want to use POP or whether you want to use IMAP, depending on whether you want to have a sync between the email client, let's say Outlook, and the email server. They also have the SPF, which is the Sender Policy Framework. So this is also related to your email. So this just helps us to do validation. Most email servers are going to have this so that we are very sure that when we receive an email, it's coming from the authorized sender, it's coming from the right place. So for example, you want to know most of these protocols, know their application, know their port numbers. Like I said, it's a very nice thing to do for your notes in preparation for the exam. Email security. So this comes handy also. Normally, when you're doing email forensic, you can use the DNS checker or DAMAC checker. So DAMAC is domain-based message authentication, reporting, and conformance. You want to see if an email is active one. You want to see if it can send mail. You want to see where it's piggybacking from. That is domain name service is piggybacking from. All of those information can be gotten from any of these two services. Now, for email security, you can have an email gateway control point for all incoming and outgoing emails. You can use anti-spam filters and antivirus scanners. Most vendors like most proprietary vendors like Yahoo, Gmail, Hotmail, they normally have scanners. And for corporate emails, you can actually, that's you have a name, you can also implement security for your email. So it's very critical, it's very important for your protection. So one of the things it's going to do for you is going to help to see when an email is sent to you. It can be able to tell once it has finished scanning if URL, if attachments, if all of those things are suspicious. That's why they're able to say, okay, we're going to push this to the spam. We're going to maybe that's why you see even for some servers, you can actually configure and say you want to have things like a box trapper. So if an email meets so and so requirements, or if it has so and so keywords, trash it. So that's a very nice way to have your email secured, because once you get emails that you're supposed to get, and of course, depending on whether there is thorough training for all levels of your enterprise, somebody might click on that email and make the entire company vulnerable. The email data loss prevention. So anytime you hear the word data loss prevention, we're trying to talk about our data being stolen, our data being mishandled, our data being exfiltrated, right? So email is one of the most frequently used communication channels within most organizations, and it can also be a conduit for sensitive data. You don't want to encourage careless handling of sensitive data. There's this GDPR, General Data Protection Regulation, and the HIPAA, the health regulation by the US, and the payment card industry standard. So this is for payments. So they all have their standards. Now, some of this is for payments. So MasterCard, Visa, most of the big payment processor banks, they comply to this. Health comply to this. Then generally anybody that uses data, and you might be asking, how does this concern me? I mean America, I mean Africa, I mean Australia, somewhere else, because this GDPR, this General Data Regulation, this General Data Protection Regulation is an EU policy on data. So data at rest, data being processed, data in all the states where you have data, we want to make sure that it's used properly. That's data handler, who is handling the data, who is processing data. And because you have global companies in the US, in Europe, because an EU regulation, I think sometime in 2018, but most countries have domesticated this regulation. No matter your country, most likely you have, like in Nigeria, we have the NDPR. We call it National Data Protection or Nigeria Data Protection Regulation. So it's an adaptation of this regulation, because take, for instance, everybody, no matter your country, you use Gmail, you use Yahoo, you use Zoom, you use softwares. And these companies have to, Euro-based, have to comply with the GDPR regulation. So imagine if Google, for instance, that's domiciled in the US, they have an EU branch, so that EU branch have to meet that regulation. And it then means that all their users from anywhere else have to meet that particular regulation. Okay, so you want to prevent unauthorized sharing of sensitive information. Actions that you can do is blocking the email, alerting the sender, encrypting it. You can also do DNS filtering. You could use your router, you could use a software, you could use you can use a DNS service, you can, whatever it's more convenient for you. The idea is you want to block either malicious websites, you want to block some kind of content, depending on what you want to do. Some options for you to use is OpenDNS. Clean browsing is a very nice tool also you could use. It's subscription based. You also have Cisco Umbrella, Cloudflare DNS. They could help you actually limit what and what. Like today now on a task I was working on in the office, I had an issue with a website not being able to access something because of the Cloudflare DNS server we're using. And we had to make sure that the Cloudflare server was not blocking a particular IP address. So you can actually filter what kind of IP address you want to be able to have access, what type of websites you want your users to access, and that is all possible if you use any of these services. So DNS security. So DNS, your domain name service, contains valuable information about hosts on a network. So what you don't want is for people to exfiltrate data. That's one of the things you could do. You can piggyback your DNS on a CDN and maybe use cloud technology to protect people collecting all of those information. So at least you protect your data from a good percent of persons. Not that some of this data cannot be gotten. It still can be gotten. You can actually do reverse lookup, DNS reverse lookup. But at least the goal in security is to minimize the risks, right? You want to minimize the risks to the barest minimum. Okay. So we've looked at secure protocols, transport layer protocols, TLS, which is the updated version of SSL, secure directory services. Don't forget LDAP is plaintext. Simple network management protocol. Then we looked at other services that we can have. Like I gave a text, I said you should make sure that you understand the service, the protocol, the adaptation or application. So you could use any of those tools and try out DNS filtering. If time permits me, I could still come on the channel and do a series for all of the labs. So if I get enough comments, if I get feedback, if I get your questions, if the engagement it's worth it, I'm going to come back and try to run most of the labs that you have in this series. Now let's look at cloud and web application security concepts. Now, we looked at cloud earlier on where we talked about the different types of cloud: infrastructure as a service, platform as a service, function as a service, code as a service. Those are the different integration of cloud. We also talked about what are the things we talked about? We talked about the, just my memory serves me right. We talked about the different providers. We talked about AWS Azure by Microsoft and Windows, and Google GCP. We also talked about making sure that we have a secured system. Now, most times our code, we will push it to the cloud. Not many times, some people use the regular host servers, but at times, our web applications can sit on regular servers. At times, they can sit on any of these big cloud providers. So how do we make sure that we have a very good, a very secured code base? Now, let's not go into the pressure of trying to release an application and not think about security. Because if you want to create an app, you can, even with ChatGPT, you could just create something very, very swiftly and very, very fast. But while you're trying to create, or you go pick up a template and launch the application, but while trying to do that, make sure you follow the OWASP guideline. The Open Web Application Security Project is a very wonderful project for developers. They have tons of guidelines. There's even a cheat sheet that you can use to make sure that all of the 10 items and their subheads, you go through them and make sure you have a secured app. So you want to implement good coding practice. You want to sign your apps, especially if you are pushing it to any of the stores. You want to have secured cookies. You want to do static and dynamic code analysis. So for the static analysis is where you pick a script, or you pick a part of a code, a section of a code, and you want to analyze to see if there are flaws. Whereas for dynamic code analysis, you could use some softwares to like run the application and see if it contains malwares. And also peer review comes handy. Your colleagues, you can interact with them and you can collaboratively check up your code base. Now, input validation is something that a lot of developers don't do. Imagine where you have a form, and that form, somebody's, the form says your email, but numbers can enter in. So that is data type checks. You are not validating that particular form. And that's a vulnerability. So at times somebody says, you asking for age, and somebody puts 300 years, where you know you're not in the medieval, or you're not in the 100 BC or 100 or 50 BC. In this present age, you typically will not get somebody that is maybe, even for the kind of project you are working on, you might not get somebody that is above a certain age. So you should validate. You should put a range that the person can use. You can also match patterns, right? You can also try to do cleanup of your code, because these can constitute and make you have SQL injection. So all of this validation needs to be done if you want to have a more secured code. Other things you could do is you don't want to expose so much of data. You want to conceal your error messages, because imagine if somebody comes on your application and he does something and he throws up an error and says niche server, or Linux, or says this, or says spills out the platform you are using. That gives the person an inroad to start doing reconnaissance and footprinting. So you don't want to expose so much of data. You want to handle your error messages very well, because if you don't handle your error messages properly, it's going to lead to data exposure. If an error happens, take somebody to a 404 error page, or take somebody to a contact page, or take somebody to a page where you say, okay, please, sorry, what you're looking for is not found. You can contact us for this. But if you allow the system to throw up its natural error code, it might throw up things that you don't want it to throw up, right? So these are ways you could protect your application. Memory management also, you want to make sure that you allow enough resources. You don't want to be having 501 errors. And don't forget that you shouldn't do your verification only on the browser, maybe by JavaScript. You should also do that on the server side. That's going to ensure that you have only the right data in your database. Okay, so this Joe Sandbox Cloud can also be used to test your applications or test your script. Or even if you get a script, if you get a template, you could just upload it on JSandbox Cloud and see if it contains malware. A very nice thing to do. You can use VirusTotal. You could upload files. You could check URLs. You could check IP address and see if they contain malwares that you shouldn't be using. Okay, we talked about secure code techniques. We talked about application protection. We talked about software sandboxing. And please, I want you to check out the OWASP, Open Web Application Security Project cheat sheets, right? Okay, so that's all for this module. I'm going to see you in the next module.